Hello, everyone, and welcome. Good morning, good afternoon, good night, wherever you are. I'm based in Amsterdam, so for me it is good afternoon. Welcome. Hello, everyone. And let me put my own TV on mute here. Otherwise, we're hearing the greeting double. So welcome to Let's Talk About AI. We're going to talk about AI for the coming 2 hours. We will have guests, we will have demos, so this can either go totally wrong or totally right. So I hope you're going to enjoy it. So quick note, this show is also going to be on Learn TV, the new TV station that is launched during Build and will kick off right after Build so you can continue learning. It will be every Thursday from 4 to 5 Amsterdam time. And I'm joined today by Tess. Hi, Tess.
Hello, how are you?
I'm doing fine. What about you?
I'm doing great.
So, who are you and where are you based?
So I'm Tess. I'm from Sweden, and I'm a developer at Microsoft. I'm working a whole lot with AI and ethical AI, responsible AI.
Cool. So I noticed we are wearing matching t-shirts.
Yes.
So what is that all about?
I don't know. I just got this in the mail, and with a sort of like a note that said "wear this or else." So I don't know. Do you know?
So we got these packages from Willem. Hi Willem, and apparently we all got them. Except
Yeah,
for Sally.
strange, isn't it? It sounds really, really weird. Why would I do that ever? So I've got the same shirt. Ha! Very, very cool. Um, so you got this because I felt the need to make some more noise for the global AI community. So the global AI community is a global organization. We help local communities set up their own meetups around AI. Learning together, talking about AI together, just generally having fun with computers. Um, and we support local meetups with stuff like ready-made workshops, demos, stuff like that. And we organize global events from time to time. Last month we had a virtual tour, so we had to move our global tour towards the internet because of the whole Corona thing. But yeah, people could sign up, watch us on YouTube, stream for 30 hours straight. It was a huge amount of work. And a couple of people that I would also like to introduce helped me set up the stream. So Hank helped me. I know Tess was there to give a talk.
Yeah.
Eve was also there. She's one of the hosts that also helps us with our YouTube channel that you can watch. And last but not least, Sammy is also here. And he's frequently helping people get their AI talk on the internet on our YouTube channel. So yeah, that's why you all got the t-shirts.
Complaining, Sammy, because you're not wearing the global AI t-shirt. What's going on there?
I know something went wrong with my address.
Oh
Wow.
boy. Yeah,
Let's see next year.
Sorry, man. But you got the collector's edition of our t-shirt.
Yeah,
right?
I have the crew version.
Yeah. It's even more awesome.
Yeah, that's version 1.0. Yeah, we were 2.0.
Yeah, the newer version. But
Hey, old school is also nice.
Yeah, your shirt is a lot older and it's a lot more rare. I would say so. Oh well.
Before AI was cool. I think.
Right before the hype.
Exactly.
Cool.
Thank
So
you.
what do you have coming up, Hank, for us?
Yes, what do we have coming up? We have like some fun demos. Tess and I are going to talk about some features we're going to show off, and then we are going to let you talk about the cool announcements that were made on Build, and hopefully you brought some code. So let's switch back to Tess and me with a nice effect there. So Tess, you have been working on something cool lately that is called video action detection.
Yeah.
So can you tell more about that?
In fact, I've been working on a couple of projects on video action detection, and one that I was talking about in the global AI community, but also in a few other places, is this one that I thought was really interesting, where we took soccer games or videos of soccer games and built highlight reels from them. Something that, there isn't a cognitive surface for that for sure. But I wanted to talk a little bit about sort of like how we thought about this and how we could still sort of involve a lot of the features that we're talking about at Build and before. So the idea then is take a matched video, get some highlights. So initially, what it would look like would be something like this. You have a matched video, you have a number of people that sit there and yes, sort of click every time there is an injury, or every time there is a shot on goal, or every time there is an attack or something like that. And then you build an expert system to get the highlights. That's how it works without machine learning. Our job was to take this and then replace it with models. So take out the people, because that's the costly piece of this, and then have one model, for example, for a shot on goal, one for a red card, one for injuries and things like that. Now, in order to do that, so in order to look at the shots on goal, you don't necessarily sort of go from a video and say, this 5-second video contains a shot on goal, but instead you'd have to look and sort of, just like you would in any software, sort of break it down to its essential pieces. So its essential pieces in this case is figuring out a couple of things that are very important for shots on goal, like a loud crowd. The crowd is sharing a lot, or people are moving very fast on the soccer game, or they huddle together, like you have multiple people, maybe a defender and the attacker. You see a goal, or maybe you see some very important people, like Zlatan Ibrahimovic. He was like in 90% of the goals, maybe, and poses. So do you think any of these, if we break it down to any of these pieces, Hank, do you think that any of these could fit sort of in pre-built models?
Yeah, maybe a little, but I don't think so. If you want to do celebrity detection, that can be done by the computer vision API. So I can't repeat the name you were saying.
Zlatan Ibrahimovic.
Exactly, that one. If he is famous enough, then he would appear in like the celebrity section for the computer vision API. But
yeah,
I guess that is about it at the moment.
So the way we thought about it was it turns out that there is actually a lot more than that you can do. So if we have building blocks, we can sort of create a lot of these models by building blocks like Lego pieces. So we could do, for example, image classification. Is it a cat or a dog, but is there a goal or is there not a goal in the picture? There are pre-built models for getting the skeleton of a human that we could use to figure out what the poses are. Or, for example, face detection could be one that we could use for forwards or special players. Maybe some segmentation to remove the background, to remove like the grass or things like that. Or object detection is also one that we can use from cognitive services or other pre-baked models to determine like where the players are, where the ball is, and that sort of thing. So, for example, for the loud crowd, there's definitely, maybe not cognitive services, but other libraries out there that we don't have to necessarily build that have to do with, or that can extract sort of like how loud it is or what pitch it is and if they're booing or not, because that will give a very different level of pitches and sounds and things like that. So an audio model, just extracting that kind of audio, turned out to be very, very useful for this. For something like figuring out if the players are grouped, in order to create a data set to actually capture that type of information, what you can do is something like this, where you split the image into sections, in this case maybe 10 sections, but it could be 100, and then you would do object detection around the players, and then you would say, for example, in this section, if I have 2 or 3 or 4 people that fit in this section, then that's a grouping, and then that could be used as input for a machine learning model. So that's a way to build that kind of feature for something that conceptually are the players huddled together. You can do that by sort of breaking it down into easier parts. And in order to figure out basically where the players and the sports balls are, this is literally the amount of code that you would need to get that information. This is a pre-baked model, a ResNet model based on the COCO dataset. So the COCO dataset is a dataset with 80 different items like people, sports ball, car, cat, dog, things like that. So 80 different categories of items. And you used to do this. Now it takes a little toll on your GPU, but this is literally the amount of code you would write. Something like the speed and direction. For this, we actually don't even need something like machine learning. We can use simple image processing. And a couple of things that you have to think about when you create these models is that you can both use machine learning and non-machine learning and sort of pull it all together. So this is using something called optical flow, which is essentially following a pixel between two different frames or between multiple frames in a video. And finally, the player poses, we could do that by getting like pre-baked models to determine where the skeleton is and things like that. This did not work very well for us because, as you can see in this picture of my daughter playing basketball with her opponent, once people are huddled together, the skeleton gets picked up as one skeleton, even if there are multiple people in here. So you have to think about that and think about if that's a use case. So the point of all this is that even when you have a very complex thing that you want to put together, it's only a matter of like breaking it down to very small pieces and summing all those together. So does that make more sense, Henk, as far as like, can we now use some cognitive services for this, you think?
For this, no, not yet.
Not yet, okay.
You can use a Kinect maybe for this,
Yeah.
but that will be weird to have a Kinect like on top of the camera next to the sports things. So that will not be good. So I want to talk a little bit about machine learning on Azure. So we've talked a lot about cognitive services, but what are cognitive services actually, and where do they fit in this and this whole picture? So I always like this picture because it shows like machine learning in like 5 layers. So there are pre-trained models, otherwise called cognitive services. If you want to do a little bit more, you need a training framework. So on the cloud, you can run everything, of course, because our machines are running on Ubuntu. So you can train all your models. There's some productivity tools to help you make it a little bit easier if you want to do it yourself. There is a lot of infrastructure, and of course, we can help you deploy it to the cloud. So I want to zoom into these top ones, the Microsoft Cognitive Services. So cognitive services are pre-trained models in the cloud that can do things for you. So there are around 40 of those services available, and they're divided in 4 regions. So we have vision, speech, language, and knowledge. So there is vision to make your application see, speech to make your application talk and listen to you, language to understand what is being spoken, and knowledge if you want to tap into the knowledge of the internet. And some of your problems might be able to solve with vision, because vision can do object detection. There is a custom vision service where you can add like a few images and it will train a model for you. It's like face detection. For speech, there are services that can extract words, do speech to text and text to speech, and do like speech authentication. Language can like extract like important things from sentences, and you can use it to build like bots from it. And knowledge, there are a lot of APIs that enable you to tap into the knowledge of Bing. So I want to show you like a demo of the Face API, because I think that is a perfect example how you can leverage like big power with AI from a developer's perspective without having to know how to actually do that. So I'm going to share my screen, and we're going to dive into some code. And it works at once. I love it when that happens. So this is the Azure portal. Hopefully everyone knows how the Azure portal looks. So you go there and you can create a Face API endpoint. You can also use the Azure CLI, or you can use ARM templates to do it. But for demonstration purposes, we are going to use the Microsoft portal. So we will go to AI and machine learning, and we click Face. You enter a name, you type which subscription it has to run in, you select a location where you want to have your endpoint deployed, select the pricing tier, and you select a resource group. I've already created one, so we don't have to wait for this endpoint to be created, but it only takes like a few seconds before it is actually there. So we are going to write some Python code to actually do the face detection and face identification. So we're going to do two things. We're going to detect people, and then we're going to identify them. And we're going to train a model for that. So first, you have to install the Python SDK. Pip install Face API SDK. And then we need some code. So the first, what we need to do, because this Python, we have to import a lot of dependencies. We need some variables to connect to the endpoint. Don't copy it, please. And then we can create a face client. So I'll run this. We can create a face client. Then we need a few helper methods to make my life a little bit easier, so that we can actually draw a rectangle around persons, and that we can put some text next to the face where it is detected the face. So we will take that, and we need to have a font for that. So to detect faces, I have a family from the 70s show, and we're going to detect their faces in a group photo. So let's do that. So first we need to open the image. This is called everyone. Everyone is on there. And then we only have to call one method. We have the face client here, and then we say face detect with stream, from stream, however you want to call it, and give it the image we have loaded in. And now it has put all the faces it detected in the detected faces array. We can open the image, and then we say draw the image on the screen and draw rectangles around the detected faces. So let's see if that works. Let's run the cell. Bam. And here we are. The faces are perfectly identified on the image. You see where they all are. And basically that is just by a few lines of code. They're actually all in here. So instead of showing it, I can just do like a quick print of what is array. Okay, it is probably better to actually show that here. Print face, then we will see.
So Hank, so far you didn't have to train anything. So far you're just using the API to detect things, right?
Yes. So it is only sending an image and coming back. I'm now using the Python SDK, but there are also C#, Java, Node SDKs available, but there is also a plain API. So you can just write your own SDK if you want that. So the fun thing is now I'm just drawing where that face actually is. But you can ask a little bit more. It can also describe your face, or at least it is trying to. So what we can do, we can, at this method, we can ask if it can return something. So we ask, hey, can you return some face attributes for us? This is an array. So we want to know, what do you want to notice? Age.
Yeah, I
Yes.
definitely want to know how old Stephen is. I
Want
think.
to know how old Stephen is. Okay, let's try that. So let's do that. I didn't put it yet, but the request works. So let's draw that in the screen. And bam, there is your answer, 34. And for who don't know,
Wow,
Stephen is,
I thought it would be like something like 18 or something.
yeah, it is not very positive on this for everyone, I guess, at that stage in time. So, but yeah, it would be great because yeah,
So,
you
so
know
hey,
Stephen
sorry,
is.
can I just
Yeah.
ask you something that Matt was asking? My company is using machine learning to detect production numbers and parts using the production cycle. We have everything running locally. Is there any incentive why we should go to Azure?
Why we should go to Azure?
I think it is because then you can have sort of like with Azure machine learning that we'll be talking about later, for example. You can do model management, you can do versioning of your data sets and things like that if you don't have that working locally, or a lot of like the metrics and getting that, and also to be able to run, for example, on different computes. So maybe you want to run parts on CPU and run parts on GPU and things like that. So
yeah, exactly. And I think the great idea is that we have like scalable clusters to train your models on. So if you want to train it, it will only spin up the compute you need. So you don't have to invest like in every time the new GPU. So Azure will do that, and you just pay per minute for that specific GPU you use. Or if you want to use 20, they're there. So I think that is also one of the benefits. And indeed, like model management, that we can handle like model managers as you would handle like NuGet packages. So you store them and you can connect them. You can connect to it. You say, hey, I want my 70s model. Please give it and give this version from it.
And then I think Code with Thieves says, my experience is also that moving to the cloud is that compute resources are a bit more simple to gather for a specific model and then free up the resources, which was, I think, exactly what you were talking about there.
Yeah.
Cool.
So
yeah.
now let me phrase it correctly. We've detected faces in the image. We only detected where they were, which location, and it described the faces a little bit with an age in this case. So is it time to move on? Because I know who Stephen is after talking to you, of course, but it would be great if it can plot all the names under it. So let's move to the face identification part. And for that, we need to actually train a face group. So let's do that. So the first thing we need to do is to create a face group, a person group. The person group can have persons, and you can add faces to those persons. So you can add multiple faces to a person. So let's call this on build. So this is a fresh face group, a person group. I also call it face group, but it's actually a person group. And here I have a directory with different photos of the cast, which I'm going to use to create the persons. So these are just one image or one face per person. So I will loop. Here. So what I will do is I will look in that 70 shows train directory. I will walk through that directory. I will remove the JPEG, and then I will have the name. I say person group person create, and I give it a person group ID and the name. Then I'll load in the JPEG file, and I say add face from stream to this.
So this is basically to create a data set between name and image.
Exactly, yes. And I can add multiple faces to one person. Okay, let's do that. It's now looping through the directory, and it is creating the persons. But they will not work. So first we have to actually train that group. So here it is just like a while loop. So we train it, we say person group train, and we give it a person group ID, and then we can ask for the status. So these are only 10 persons, so it will go like really fast. We don't even have to wait like 5 seconds. It is like bam, done. But if you have like 10 to 20,000 people in it, it takes a little bit longer to actually train it and go to.
Right, but that was super fast.
It is extremely fast, yeah. So now probably we want to see if it has worked. So we have to do 2 things. Already one thing we have done. So we load our test image again with everyone on it. We open the image and we call detect with stream. Exactly the same function as we called before. But what happens is that they all get temporary face IDs. So those ones live around 15 to 20 minutes.
Mm-hmm.
And we can get them. So we loop through all our detected faces and create an array with face IDs. And we give that face ID arrays together with the person group ID to the identify method. It will start identifying, start matching those face IDs, or however it works. We will dive into that later, to the other persons. And then we will get back an array with results. We load in the image, we put the image on the, we load in the image indeed, and then we loop through the detected faces. If we don't know a person, then it will draw 2 question marks. And then for every person in the result, we see if there is a matching and if it has found a match. And then we put the detected person .name here.
Oh.
So what you have to realize about this extra method here is that this method will not give any identifiable information. It will only give back the person ID, which we can later on use to actually get our stored person ID from the face API. But we can also use, of course, that person ID to connect to our own database to actually get more details of that person. So we don't necessarily have to store everything in this face ID, in this face API. So we draw again the rectangle around it, and we print the name of the person under it. So do you want to see if it works?
Yes.
Perfect. And it is working.
Woo-hoo.
So Stephen is there, Donna is there, Fez is there, Michael is there. So
I thought you said you wanted to be part of like the whole 70s family.
yeah, that would have been cool, eh? So I'm happy you asked, and that I can actually show it off now. So I have another photo with me popping up in the 70s show. So how does that work if I want to add myself to this data set?
But hold on, were you actually there?
Yeah, I was actually.
That's a pretty bad cutout, man.
I will do it like very fast. That's okay. So nobody sees like my amazing Photoshop skills. So it is there. So the only thing I need is a picture of me, because I'm just going to create a new person and add a face to it. So let's go here and get some more code. So we're going to repeat exactly the same loop as before. We're looping to the directory extra faces, and we will add this person. We will add this person to the person group, and we'll add the face to it. And my name is Henk. So now we have to retrain the the person group. Otherwise, it doesn't work. Train it again, and it should be done also like within a second. And then we can actually load in the other image. So let's go back here, everyone, and this time with Hank in it.
Hey, I think the crowd thinks that you should have used deep fakes instead
Yeah,
to get in there.
then it would have probably looked a little bit better. But yeah, I'm here, and we see that just it is here. So the main point is, of course, showing how easy it is to add like another person. You don't have to retrain it with all the images. You can just keep adding persons. You can also keep removing persons from it. So you can hook this up to like your company. For instance, if someone goes into service or out of service, you just add a face.
So this was sort of like out of the box face API from Cognitive Services that you were using here.
Exactly. I think how many calls did I do? Like 5 or 6,
Mm-hmm.
and that's it. So, but yeah, this is really really great that it works out of the box. But I always want to know how it works underwater. I don't know, but luckily Tess does. So maybe you can share a little bit on that.
Yeah. So let's see if I can try to explain it a little bit. So all of this works because of something that is sort of like the magic of machine learning and deep learning, which is called embeddings. So embeddings is something that gives semantic meaning to your face, for example, that can then be used to differentiate your face from someone else's face, to make sure they know that it's you and not Stephen, for example. And embeddings in themselves is just trying to make a little bit more out of the image or the word or what it might be. So if you think about a word like apricot, peach, beach, and if you would just compare them as words, you would say, okay, so peach and beach look very, very similar. They're probably very similar, but this apricot thing is like completely different. We have no clue what that is. But it turns out that if you would actually know what they are, if you actually had some semantic meaning to them, you know that apricot and peach is literally the same thing, give or take. You can make jam from it, but then beach is something completely different, and you can't make beach jam. So how does a machine learning model then understand like this semantic information? If we take another example, actually, if I would recommend you a book, and I have like this huge library of really good books, and I would recommend you something, one way that I could do this is by sort of sorting it a little bit. Maybe I would sort it by things that are good for young people and things that are good for adults, and then you would be on the far right here because you're very old, like at least 34 or whatever you are in that picture.
Yeah.
And then I could give maybe some more meaning to it, because maybe it's not just young and adult, maybe it's like you like fiction or non-fiction, or maybe you have some other features. So what is cool about this, if we just look at it from in the two-dimensional space, because it's easier to look at it like this, we can then assign some numbers. How adulty is it, or youthy is it, or how fictiony or non-fictiony is it? And we can say it's like a minus 0.6, 0.4, and a 0.7/-9. And we can see that the closer something is, because this is sort of like the geometric magic with embeddings, the closer something is, like in this case, for example, Hunger Games and Divergent, the more similar they are. So the bigger chance that if you like this, you like this. Or if this is your face and this is something very close to it, it's probably the same face. Now, here we only have 2 dimensions, but we could of course add like much more. Is there math references? Is it US-centric or shit-licked or funny or sci-fi, or does it have lawyers? Or would Brad Pitt play a character in the movie of this book? all of these features together, we don't actually make up the features, machine learning makes up the features, but all of these features together means that we can now represent the book or the word or whatever we want with just numbers, with just a set of numbers that clearly describe this and makes it easy to differentiate it between this and another book, for example. Now, I don't know why that played twice, but we can do the same thing with a face. So we can reduce your face to a number.
Okay.
Which is
You're
exactly what
saying,
it is.
oh, hold on. You're saying that I'm a number now.
Yeah, you're actually 128 numbers, but yeah, you're a number.
That's 128, yeah, but still, it is just numbers.
Yeah, it's numbers. So I'm sorry, that's all you are, man. It's a sad realization. But the cool thing about only being a number, though, is that it's very easy to put these numbers in a database, right?
Yeah,
Storing like 128 numbers that represent my face is so much easier than representing like storing sort of all like all the images and or maybe 100 images of someone. So this code or embedding comes from, like, this is a standard picture of how a neural network works, like a CNN, a convolutional neural network. The embedding comes out here in this part of like this. I'm sure you've seen like a similar picture a lot of times. This is the embedding, the thing that comes right before we do the classification. So this is like the secret sauce, the embedding, the intermediate representation, the secret code. And when it comes to images, then what this means is that if I take a lot of images of a person, like all these images of me are the blue ones, then those are all grouped together. And we can do some simple classification, like logistic regression, which was what you were doing actually in the training, to separate my pictures from pictures of Tom Cruise, for example. It turns out that it looks like I'm kind of similar to Tom Cruise actually in a lot of my pictures, which will be important later, but also Sandra Bullock, which I'm maybe a little bit more happy about. But this is why you could train it so fast, because you only have to train sort of like the logistic regression, or like the cut between these two sort of like image groups. So when it comes down to asking a question like, is this Tess? Or who is this? Or group all my images of all my people, it simply becomes like a query. Like if the distance between this image, like the sort of like the point in 128 dimensional space, and another point that represents the image I have on disk, if it's smaller than some threshold, I'm just giving an example, 0.2, then it is me. Or looking for someone, this is what you did. You did a for loop. You looked through all the pictures that all the people you had in your database, and you say, if the distance is less than 2 or whatever, or less than 0.2, then this is the person I'm gonna guess it is. And if there's no one that has like this distance, it's a question mark. Or grouping becomes a simple query of doing like a k-means clustering or something like that. Now, there is some problems with this, though. And one of the problems is what we actually saw. I don't think Stephen was actually 34 in that case. And similarly, I'm sorry, but I'm not 26. I wish I was, but I'm not 26 anymore. But even worse, I'm also not a man. Maybe this is like because I looked a little bit like Tom Cruise in some pictures or something, but it's probably also because there's a sort of like a discrepancy in the training material where maybe it doesn't have like as many females as males and so on. So this causes problems like this kind of problem where it hasn't been trained on a whole lot of people with an Asian demographic, so they don't realize like this looks like someone is blinking. Or other problems actually that also show up in machine learning, is because you don't think about them, are things like this. The Chinese police uses facial recognition to send jaywalkers an instant fine by text. What could possibly go wrong with that? Really? So one of the things that could go wrong is that machine learning can't differentiate between live people and someone on an ad on a bus, right? So this person got fined a ginormous amount of jaywalking text because she was always on the zebra crossing when it was red. And in a case like this, obviously the machine learning was doing what it should. It was identifying her, everything was fine, but things can go wrong. And then in a case like that, you have to have safeguards to make sure that when things go to shit, you can actually have someone that comes in and can help out. Sort of like if, for example, someone gets fined maybe 5 times in a day, then there's a safeguard that says, hey, we need to look at this. So this sort of brings us into the next section of what we're going to talk about, where Willem and some other people are going to help out with coding around some of these things. So making sure that we create fair and accountable AI, like responsible AI, right? So a couple of things. This is a list of what we're thinking about in Microsoft when we think about responsible AI. It should be fair and inclusive, and we're going to have a demo on how you can make sure that your AI or your machine learning is actually fair and sort of like works the same for all different demographics. Transparent. This is, can we interpret the results? Do we know how we got to the response? So we'll have a look at that with Eve. And accountable, having a human in the mix, safe and reliable. I think we're going to have a look at that too a little bit later, and also how you can make sure that your data stays secure and private and that you're not leaking information with your machine learning models.
Exactly. Yeah. So at Build, there were like some announcements on those frameworks, on the things you just mentioned, like around fair learn, interpreted text, confidential ML, and white noise. So that are the topics we're going to dive in. But it was kind of interesting that you said the machine learning model was actually doing the work, was doing the correct thing. So that also puts, like, if you're working as a developer on AI systems, that it puts also a lot of responsibility by you as a developer. At least I'm a developer and I will get like a model and I will trust the model. But you, the whole team, has to share that responsible, not only like the one that creates the model, which is basically just one.
But I think that's sort of like the same with anything. So as developers, we're also sort of like responsible for making sure that no one can hack our systems, and so adding security, adding things like that is the same as adding like responsible AI to your models.
Yeah.
Does that make sense? Yeah.
That makes absolutely sense, but yeah, I wasn't aware of those things like as a developer like 5-6 years ago. So that is like a whole new thing, at least for me.
Yeah, no.
I'm also accountable for that part now, that we also have to test it. Even if you're a tester, you somehow have to find a way to validate these things.
Yes.
So Willem has some tools for us that can actually help us with that. So hi, Willem.
Hey.
You're black.
I'm black. I'm not black. I'm pretty sure I'm here. Let me reset my camera. That might help. Does that help?
No, not at all, but maybe it is just me.
Maybe we should just go to your screen instead and see.
Yeah, let's do that.
Oh, no,
I want to share some code, man.
You're there. We will see.
Oh, great.
I don't have to hide you. in this scene. That would
Oh.
be nice. Yeah. Good. Hi, Willem.
Hey, I'm
How
back.
are you?
So my skin color changed back to the original one from black.
Yeah,
Pitch black,
you're not a
actually.
black box AI anymore.
Yeah, not a black box model anymore. Let's.
Yeah, so Willem, can you tell a little bit about what you do in your daily job?
Yeah, so I work as a technology advocate for info support. My daily job is actually helping people get started with machine learning, reinforcement learning sometimes, data platforms, that sort of stuff. It's all around data, building smart machines, that sort of thing. And I'm really getting people started. And after that, my colleagues will know. I will leave in about 6 weeks and I will say, well, that was fun. It works. Good luck with the rest of it. And I will move on to the next customer, actually, getting them started with the project. I will keep in touch. That's how it works in my job. It's not a 9-to-5 thing, but yeah, it's a lot of fun helping people get started with new AI stuff, teaching them all the finer points of building a model.
Cool. So you've been involved in these build announcements about
Yep.
very specifically FairLearn.
Yeah.
So I want to see some code and want to know how it works because we all see what can happen. So what can we do to prevent a little bit of that?
I'm hoping I can prevent my screen from sharing. Yes, it's working. Oh. Whew. Yeah, my computer starts acting up, so you should be able to see my screen now. So let's talk about FairLearn. So Microsoft announced during Build, at the beginning of Build, that Microsoft is putting more effort in building tools towards responsible AI. And one of the tools that I'm going to show is FairLearn. What is FairLearn? Well, FairLearn is a package that you can use to measure fairness of your model and also fix fairness problems with your models. And the first part, measuring fairness, is actually looking at your model and making sure that it's inclusive for all groups of people trying to use your model. And the second part is once you know that your model is fair or not, making sure that it's more fair towards groups of people that are using your model. So in the case of the picture of the women of the woman on the sidewalk on the I would say zebra pad, sort of a weird Dutch way of saying it. Yeah, in that case, I can't solve that with FairLearn right now, but since it's early days still, but I'm pretty sure they can improve models in that case as well in the future. So the demo that I wanted to show you, the thing that I've been working on the last few weeks, is actually a model around giving out credit cards to people. So what I've done, imagine, if you will, a credit card company that's going into 2020 and saying, I want to give out credit cards to people based on data rather than having to manually score all the credit card applications in my company. And this company uses one model to do that. Actually, they are using a model that's sort of switched around. They're going to predict whether you are going to fail to pay your credit card bill next month. And if that's the case, they will not give you a credit card. So that sounds kind of weird, but this company does it and it works for them. Well, at least we hope it works for them. So let's find out what's going to happen. As any good data scientist knows, you can write Python code in notebooks. I'm going to do that today as well because I'm going to use some visualizations just to demonstrate how this FairLearn package works. So I've pre-trained a model, and it's in my notebook. So if you download the code from GitHub, we'll share a link to that later. You will find in there a couple of notebooks, one for preparing the dataset and one for training. And this is the third one, actually. We're going to check how fair the model is after I've trained it. So what I'm doing is, first, I will import the necessary packages to get a dataset in my model. I load my model from disk. I saved that in my previous step. And I'm going to load up a training dataset and a testing dataset. And the first one I'm not going to use immediately. I'm actually looking at my improving notebook. Let's switch over here first. It's pretty much the same. I've got a lot of code to go around, so excuse me. So first I'm going to load up my model, and then we're going to load up the testing dataset, which is the most important dataset in this case. So what I've done is that I do have a large dataset that contains data, historical data from customers. And it basically says, what's your payment history, and is there any indication that you're not going to pay your credit card bill? That's in this dataset. So when I can actually show you, when I do this, I can say data_test.head. I can pull up the first 5 rows from my dataset to actually see what that looks like. So there's a bunch of numbers in here. This one's interesting. The gender of the person asking the credit card, education level. That seems to me that's also a bit sensitive, but hey, some people use it. And here's the credit card payment history and the amount due. And at the end, this is the column that we're actually predicting using the model that I've trained before. So now the big question is this model going to behave fairly towards male and female customers? As we know in the world that in a lot of countries, women are paid less than men. So it could well be, in this case, that my model is going to predict that it's more likely for a male person to get a credit card than a female person would get. It can happen. It's sort of my way of thinking when I start looking at models like this. But it might not be the case. Let's find out. So what does FairLearn do in this case? FairLearn offers a widget called the FairLearn dashboard. It's it's not exactly a dashboard. It's a sort of a HTML thing that you can use to visualize how fair your model is. It needs a couple of things. So to create the FairLearn dashboard, I have to first call its constructor and feed it a set of sensitive features. So in this case, I know from experience that gender could be sensitive. We want to treat male and female people in the world equally, but it could well be that our model is not doing that actually. So that's interesting to look at. In addition to that, I'm going to feed it a set of names, feature names, and these are important because given these names, I can see in the dashboard, oh, I have to select this feature named gender in this case, or sex it says, but gender. And finally, I have to provide the ground truth for the model. So what is the expected answer of my model? And what are the predictions made by the model? So these predictions I get from saying model.predict and feeding in the test dataset. So why am I feeding the test dataset? I know my model trained on a training set. So what happens in machine learning is it's actually sort of getting really good at remembering those samples specifically. So when I want to make sure that a model does work for new samples that it hasn't seen before, I have to use a dataset that I haven't used during training. So that's why I'm using a test set over here. So let's run this and see what happens. We're going to say run all because I know this is working for me now. And what I get is my FairLearn dashboard. The FairLearn dashboard then asks me for 2 things. It asks me to select the sensitive feature first, and then a performance metric. So let's do this step by step. Let's go over it. Okay, so now it's asking me, which feature do you want to look at and assess your model fairness? Well, I haven't specified more than 1 feature, so I only have 1 option to select here, which is the gender of the person that's requesting a credit card. And then I can make a choice of different metrics. I'm not going to explain all the metrics here. You can look that up on Wikipedia. There's a bunch of tutorials explaining this. But for me personally, I know that balance accuracy is a good way of measuring model performance. Basically, it balances out unevenness in the amount of samples between different categories of inputs. So for example, if I have 70 samples saying yes and 30 samples saying no, it will balance out the number of samples between those categories and then measure how accurate it is.
Willem, Lasmat is asking, what is considered responsible in terms of accuracy in machine learning?
Yeah, it depends a little bit on what you're trying to do. So when you look at pure accuracy in this case, then it's just one number saying, well, in 80% of the cases I got it right, for example. But if you've got a model that's predicting like 4 different categories, that doesn't say a whole lot.
But does it then mean that it should get it like equally accurate for all the different groups?
Yeah, so that's the idea behind the balanced accuracy. So it should get it right in this case for both yes and no.
But also, for example, it should, like, if it's like 80% accurate for men, it should also be 80% accurate for women. Is that what we're after here?
Yeah, that's what we're trying to do this with this dashboard. Yeah, so when I click next here, I can actually show you what's happened. So what the Fair Learn dashboard does in this case, it takes all the samples that represent men. In this case, they have the value 1 for their gender, and it will measure how accurate the model is. In this case, it's 79% accurate for male customers. So like 8 out of 10 samples roughly are predicted correctly for both 1 and 0. For female customers, it's a lot lower. So what you see here is actually, it's pretty unbalanced in that sense. This top part of the dashboard actually shows me that it's very likely that it does a bad job at scoring credit card applications for female customers. And it doesn't sound too right. I mean,
so let me ask you another question here while we're on this. You selected a sensitive feature. Did that feature have to be a part of the training data set? As in, like, did it have to be a part of the model that you trained?
I can show you, actually. I haven't included it in my model. So I've got my training model, my train model notebook. And what I've done during training is when I created the features for training the model, I dropped the gender column.
Right.
I'm not interested in that. I purely want to look at the payment behavior of the last 5 months, actually.
So what you're saying here is that you're training a model, but then you keep in your data set like certain sensitive features like gender, age, maybe ethnicity, things like that, so that you can then compare them with this fairness.
Yeah, so that's important when we talk about fairness. If you want to use Fair Learn, you need to have data samples that include sensitive features. Otherwise, there's no relationship between the data that you use to train the model and those sensitive features anymore. It could be anything. And this correlation, if you will, between gender and other features in the data set, that's actually what we're trying to do here. What can happen in reality is that some models, despite the fact that I didn't feed any sensitive features, will pick up this sensitive feature because other features are actually sort of representing this sensitive attribute. So it could well be that income, in this case, is a reflection of whether someone is a male or a female person.
Right, or things like, for example, if they bought something in a lot of stores that are maybe frequented by, a certain gender or age or ethnicity, or things like that.
Yeah, that can happen, and that makes this very difficult to see with the naked eye. I did the best I could. I removed all the sensitive features that are in the data set for me, but I can't really see that in other features there's another sensitivity included because it's not explicitly listed that someone is going only to certain types of shops.
So how would you go about fixing this then?
Yeah, so that's a good question. So now I know that this is pretty unfair. Actually, a funny thing is, it's more likely that a female customer is going to get a credit card. It's sort of the opposite of what we see in normal banks, I would say. So let's take a look at improving the situation. What you see here is my fourth notebook that I'm using. It's my improved fairness notebook. And what we're now going to do is take this existing model and try to make it so that it's less unfair towards male customers. And for this, we're going to use what's called the threshold optimizer. And the threshold optimizer is a component that you sort of add on to your model and that will try to equalize the balance between male and female in this case, or between different sensitive groups in my data, in my model. The cool thing about the threshold optimizer is it's a black box approach. So I could have trained this model months ago using deep learning. Anything goes. As long as it's a classification model or a regression model, it will work. So that's pretty cool, I think. So let's take a look at how it works. So I import the threshold optimizer from the post-processing package, and I feed it my original model, and I specify some constraints. And these constraints, these are options on how you want to optimize for fairness, actually. And you have two options. You've got demographic parity or equalized odds, which is the other one. These are slightly different approaches to trying to fix the balance in your model. So once I set up this threshold optimizer, I can call fit like you normally would with a machine learning model. And what it will try to do is actually try to use these constraints to fix the model in some way. And it won't fix it completely, I have to be honest here, but it will improve by quite a bit. So let me show you what happens if I run this code. So it will take a little while. It's done, it's trained. So I can see that this cell is done. I've got Optimizer. And now I can use the Fair Learn dashboard again, and I can take a look at how well it's doing right now. So let's see. I click Next, choose the same metric again. And right now the disparity is 16%. Going back to my other notebook, it's 18%. So it's not improved by a whole lot, but at least it's somewhat better. And what you can actually do is switch between the equalized odds and the other constraints that I used and try to optimize it even further. But at least this way I got a slightly better model. And in some cases it will do a lot better. It's still machine learning, so what I could do is try to train it again and we will get a different figure. I'm pretty sure of that. Because this is actually another machine learning model on top of my machine learning model. That's what it's trying to do here.
Inception.
Inception, yeah. Yeah, it's kind of funny that you can use machine learning to fix machine learning. I'm pretty sure that XKCD has a comic about it. Just swirl it around some more and it will fix itself. But that's not the idea behind this.
So does this only work on structured data? By structured data, I mean sort of like numbers and things like that. Or does it also work on images?
Yeah, so it does work on images. As I mentioned, the threshold optimizer is actually a black box approach. So the only requirement that you have in here is that this model that I'm putting in has a predict and a fit method. That's the only requirement that it has. So if you have a deep learning model that accepts images as input, that's fine, as long as it has a predict method and a fit method to train it, then it's fine, you can use it. And I should say that right now, threshold optimizer is only working for binary classification. So if you've got multi-class classification, it doesn't really work at the moment. But they are working on that, and it should be available pretty soon, I guess. So yeah. That's pretty cool.
Yeah, very cool.
So right now, my credit card company is doing slightly better for male customers, which is a good thing, I think. And probably if we spend some more time working on the data set, maybe working on other things, we might actually get to a pretty low number. So yeah, that's what Fair Learn offers. There's one last thing. So Fair Learn is, like I said, a machine learning model. It helps improve stuff, but it doesn't fix it. And the other thing that I'd like to mention is I've just shown you the post-processing stuff that works for existing models, but you can also use this during training to actually optimize your data set before it's turned into a model. And that gives you better results as well.
So do you say that this should be part of your whole machine learning pipeline, like as an extra step?
Yeah, I would actually use it as an extra step. So I've had this discussion with a number of customers. They want to make sure that they understand what the model is doing on the one hand, and they want to make sure that it's fair. So it's a natural part of your Azure machine learning project, if you will, if you're using that. And it's just like any other model. You can actually save it in your workspace if you want to.
But more sort of on the manual side as far as like a debugging step, right? Or do you feel like it should be an automated part of like the whole machine learning model?
Oh, that I
Machine
don't know.
learning pipeline?
Maybe not at this point. So it's fairly new. It's version 0.4. I would use it as a manual step, especially this dashboard stuff that I've shown. But there are more metrics inside the package that you can use inside your build pipeline if you want to maybe flag your build as failed if it goes above a certain threshold.
Right.
That might be useful as well. Yeah.
So one thing to point out here is that you could do this because you had like these sensitive sort of sensitive features in your data set. You didn't train on them, but you at least had them. So it is quite important if someone wants to create a fair machine learning model that they actually still store all these things that they want to be able to measure. And also that you as a machine learning engineer go through and make sure that you understand where the things can go wrong. So for example, if this doesn't have ethnicity as part of it, you can't even measure how good or bad you're doing with that. Or if it doesn't have whatever other features that you feel like you need to sort of measure on, you can't do that unless you're actually capturing that data. So it's also a matter of, yes, you can do this and you can automate it and that's great, but there's the other part of understanding what you need to collect and actually run this on.
Yeah, that's a good point. Right now, that's a problem for some people that are building machine learning models because you don't have that sort of data. But I have to say that while building this sample for myself, I quickly discovered that Microsoft is actually working on a way of not where you don't have to feed these sensitive features to either the threshold optimizer or the dashboard. They will figure that out themselves.
Oh,
I don't know exactly how they are going to do that, but the documentation actually mentions that right now it's required to put in those sensitive features, but they are going to remove that in the future. So that's good news, I think.
very cool. Yeah. Awesome. Thank you so much.
You're
For this.
welcome.
I think this
Yeah.
is really great stuff.
Cool.
Yes, thank you.
So I think
Yeah,
we need
thanks
to
for
let you
having
go to do your next presentation and move over to Ava, right?
Yeah.
Yes. Hi, Eve.
Hello. How are you doing, guys?
Great.
We're doing fine. We're doing fine. So we are covering the build announcements around responsible AI. But first, before we dive into that, I want to know a little bit more about who you are. So can you quickly introduce yourself?
Yeah, I'll be trying to be very quick about it. So I am also an AI MVP, and in full time I'm working at Lærdal in Denmark. That company is aiming to save more lives with providing classes for nurses and doctors all around the world. And at this company, I am working in the analytics team as a data engineer mostly. And we are trying to make sure that the data we get, we use for improving these courses we provide.
Sounds
Yes.
like a nice job. So you said very quickly, and we had it already a bit quickly, like AI MVP.
Yes.
Can you tell what it is and what it took you to become one?
Yeah, so in this year on February, I became an MVP as a Microsoft Most Valuable Professional. I think it is a great honor to get this recognition. Since I'm an MVP, I'm doing a lot of contribution on different community events or some, I don't know, do a lot of speaking at different meetups or conferences. Also writing about some projects, writing about my my findings, like my researches and stuff like that. And I'm really trying to involve as many people as possible to get them into the field of AI. That's really my aim now, and also extend this AI, this love for AI, not just in Denmark but also all around the world, I guess.
Nice. So you also have a blog. So
yes.
Before we dive into your piece of code you made, everyone can read it on your blog, right? So it is listed below. There, I think. So you can always go there and do the tutorials again. So I would say let's dive into the code.
Yes, sure. I'm just going to share my screen.
Yeah.
And if I did everything correctly, you should see my screen. And I just closed this window here. So my main topic in this past 2 weeks was interpretability. And when we are talking about interpretability in the field of responsible AI, the aim is always to bring some explainability into often confusing and complex AI systems. So which I would like to show you this tool today that might help you to debug and fully understand your models. InterpretML is an open source Microsoft package that incorporates ultra-modern machine learning interpretability techniques. I'm sorry. And this can be viewed as a valid source for explaining black box systems and glass box models. And now, there is this new interpret text, the innovative interpretability technique for NLP models. It has been developed by the community, and it has just been announced at Microsoft Build. This open source tool allows developers and data scientists to explain their models, to build a visualization tool as well. This visualization dashboard provides you a good insight about your data. And you can also perform a comparative analysis on your experiments while running them on different state-of-the-art explainers. So now I'm going to walk you through on one of the explainers. The name of this specific one is Classical Text Explainer. So this is an interpretability technique used on classical machine learning models, and it covers the whole pipeline, starting from text preprocessing through encoding and training and hyperparameter tuning, and this all happens behind the scenes. For preprocessing, it uses a bag of words encoder, and for training, it uses logistic regression as a default configuration. But this can always be changed if you're not happy with it. And for this, there is a configuration file that can be updated. As an input model, classical text explainers only supports, for now at least, scikit-learn linear models and tree-based models. But additionally, any models with a similar layout and suitability for sparse representation can be used soon. Yeah, the API enables developers to extend or move around the different modules, such as the preprocessor, the tokenizer, the model, and the explainer can still pull in all the tools that are implemented in the package in general. So there is one more important thing I want to mention before I go ahead and show the code, is that the aim of the classical text explainer is mostly and most of these text explainers are aiming for showing you what are those important features that has an effect on the decision of your model. So now that
before you go through that, could you say, is this code example part of your blog?
Yes, I made a bit of change in the morning, to be honest, and that will be updated in my blog as well today or sometime.
So could you just mention the name of or the link to your blog again?
So that is also on Medium. I think that's the link shared right now. And then there is this codewitheve.azurewebsites.net where you can read about all of my findings and researches around these explainers. Yes, so the content will be updated continuously every time. I will mention it here and there that we can expect this and that to be added soon. So yes, So let me go ahead and show you some code. Now let's see how can we use this specific explainer. So I'm using my local computer and have this Jupyter notebooks installed on it. And here in the first cell, I'm simply getting my working directory and my environment ready. And then there is the data imported. And thanks to pandas, now I can use it as a cool data frame. And this data frame will look something like this. And what I want to do is that for each sentence, I would like to tell what is the genre. I mean, not me, my model should do that for me. Yeah, so before going very far from here, I also wanted to show you the genre, what genres we have. And that if I run this code, I see that I have telephone, government, and so on and so on. And we have how much data we have for each of the genres. This is pretty cool. That is really nicely balanced data that we can use here, which is very good, because in the end of the story, the prediction will not be that skewed either. All right. As I mentioned before, the classical text explainer takes care of the entire pipeline, and this labeling encoder is used for preprocessing. And then I'm going to prepare my data set for training and testing with the use of scikit-learn's train test split function. It might be very familiar for you. And after I'm running this code, I can see that I have 104,000 something training and 26,000 something for testing. All right, so then I go ahead and make the training. So the fit function of the explainer is available to train the machine that returns the classifier result and the best parameters. So what does this mean? This means that inside the classifier, we have the information what preprocessor we are using, that is the encoder we just configured just previously. Then we have the classifier with the logistic regression that I mentioned you, that this is the default model that is basically included in this explainer. And the best parameters will look like this. If anyone wants me to explain these things, we can do that maybe later. But the important part here, when I'm telling that we choose a classifier and the best parameters from here, is that these best parameters are only working very well with this specific problem. So if you use a different data set or you want to use a different model, your best parameters will obviously change as well. All right, so after training, it is time to score the model and get an evaluation result. So when I'm doing this, I am doing that with the test data set, and with the defined classifier, I'm doing the prediction and get to return the accuracy, precision, recall, and F1 score. And what I can see here is that my accuracy is pretty nice. It's around 84%. So my model is 84% sure about its decision, which is, I think, an okay number to start with. But how can my model tell about a sentence that it is a genre of telephone, or is it a governmental text, or what? Where is it? How can it decide? I mean, we gave it a lot of text to train, to learn from it, but we don't know what exact words did it take out from this sentence to train the model, and how did it get that result that it got. So what we're going to do here is to explain the model with the help of one of the sentences that is coming from the data set we were just looking at before, but I'm showing you again. The index 0 is going to look like this sentence here, and the genre I expect to be government. Right. So I just head back to the code, and the reason why I didn't run this because I prefer to make the show here. So if I want to explain, then the explain local function here Just a fun fact, this actually expects more than one parameters, but at this point, the extra parameter is not really able to be set. Microsoft is working on it. It should be done in the coming days. That will be included in my blog as well as soon as possible. But right now, the one parameter we can pass is the feature. But we can also pass another parameter, which label we want to get an explanation of. If it is not defined, it is going to return the default parameter. The default parameter is the one that it is predicted. So let's see some interesting thing that you can anyway get out from this explanation is that you can see what are the labels the model is choosing from. And if I run this part of the code, we can take a look at the important words ordered as the importance is, which is really cool. Now, looking at the sentence, I know that, okay, this word and that word was important, and we also have the value how important it was. And also, just for fun, I'm going to show you whether the true label that is coming from the data set and the predicted label matches. It matches, so everything is awesome. It's just, not that cool to look at the result only as numbers and words like that. For this, we can create a dashboard. I just run it again to make sure that it is ready to go. And this is how my dashboard looks like for this specific sentence and for the specific label that has been somewhat chosen, right? What we can see on the top of this dashboard is a slider. This is how you define how many words you want to see on the dashboard, how many words should be explained, whether it is used or not in the prediction. On the right side, you can see the label that is chosen for this. And then you can also choose whether you want to see the positive or negative features. What does this mean? The positive features are the ones that has an effect on the decision of the model, and the negative features are the ones who are that are not. And I don't have negative features for this sentence.
As in, like, which words made you think it was a government, and which words made you think it was not a government feature?
Exactly. Yes. So it's like from my point of view, it is it's funny, this result, and which is why I actually prepared something even cooler than looking at a sentence that maybe doesn't seem to be very governmental, except because maybe some words that my machine thinks it's important. So I actually prepared you something cooler. I prepared my own sentence to play with. And this sentence is, yeah, we had a great time at your party yesterday. Thank you a lot for your invitation. And what I can do, again, to explain that one, I am going to try and fit it into one of these labels. And now I'm asking you all, what do you think from these 5 labels, which one fits the best this sentence? Is there any guesses?
Do we have any guesses in the Twitch stream?
Yeah, okay, so I'm just going to run this code and let's see what my machine thinks it is.
I'm going to guess telephone if no one else is guessing.
Okay, so you say telephone. Okay, cool. And why?
Because that's something that I would maybe say in a phone conversation.
Yes. So yeah, it's not really a governmental speech or something.
Someone is guessing travel here.
Yes. All right, so I just run this code, and the predicted label is actually telephone. And if I'm going to run this dashboard, and I want to see what words are making this my machine to make this my model to make this decision, I can see that there are like positive and negative features. Finally, I can show you how does it look. And also, if you hover over these tabs, you can see the importance values as well. And I was also thinking about this telephone is maybe quite okay to see. Why is it? I'm using words that is not really, a nice way of saying things, right? It is more like just a free talk kind of words I'm using here. So could be one of the reasons why it also chose telephone for this sentence. And let's see the negative features where I'm saying invitation and party and yesterday that has a not effect on the choosing
so
the
those,
label.
for example, might be something that would make it lean towards, I don't know,
to somewhere else, exactly, to other labels, exactly. Right. Okay, so
Can you talk a little bit about where you would use this? Would you use this also sort of like in a debugging sense, or would you use it?
yes, I think I would start using this at data engineering already, actually, because I can see that it is choosing out the words in a manner that it might make sense, and if I start investigating the important features what my explainer returns to me, I can maybe make my featureization better for my data, so it is resulting in a better result. Yes.
And also, for example, it could show you if you had some things that it picks out. I know someone was earlier talking in the chat about, you know, like a cloudy day predictor or a tank predictor, where it's picking out things that are totally it shouldn't be looking at. Maybe
Yes.
it's picking out something that is very telling because the data set was built in a specific way. So maybe, for example, I know there's a classic one where we look at 20 news groups, and it turned out that the name of the person writing in the news groups totally gave away what news group it was. But obviously, that's not what we want a machine learning model to learn. But something like this would then go in and say, "Hey, it looked like 90% on the sender, and
Yes.
not at all on the actual words in the text."
Yes, and I think it is really important to have a good explanation of the textual analysis models, because that is often it's not a numerical data. It is almost as difficult to use as images, and I mean it's sometimes it's good to have an idea how my model is reading this text, because it's not always the same way how the model reads this text as I do.
Yeah, I could also see, for example, having something like this where you now, well, in this case, the dashboard actually highlights the words that it's looking at, and maybe having that even as part of the UI of whatever is using the model, saying, hey, these are the words that made me think. Let's say, for example, you have a model that decides if a text is hard or easy to read, and then you could point out the exact things that made the model think that it's hard or easy to read. So even using it as both sort of for fairness and things, but also as a UI element for the user to understand why it's guessing something.
Yes, that's a very good point. That it's also a really good feedback, not just for the developer, but also for the users, for the end users. Yes. Is there any questions maybe regarding to this?
We have any questions from the stream?
Okay.
I think we have a bit of a delay because last time when we asked for for what categories, we got some fiction and some things afterwards.
Nice, but that's cool. Some people are trying to guess. That's nice. I mean, I think it's fun to play around actually with these models, and I would like to also mention that there is something important as well. We have talked about when we are talking about explanation, and when we try to explain a model, we often mention this local and global explanation, and the reason I didn't show global in the classical text explainer is because this explainer only explains locally, and but we
So
have
maybe
this.
you should explain what local and global means in this case.
So yeah, I'm going to try. So the local is only explaining one label, and like we see now.
Or rather, one piece of text.
Yeah, exactly. Yes. And well, it's yes, and then the global is for an entire document. It's I have not really tested that thing yet, to be very honest. So I am not sure what is the exact difference in the end.
Yeah, so I think it is that the local is why did it explain this particular instance like this, but the global is sort of like a bigger understanding of how the model works and what's generally important for the model, like what things are are generally important to make a decision, not only for this piece of text, but for any piece of text.
Yes. And before I stop this, just one more thing came to my mind that what's coming soon, because that's interesting to mention. I don't know if I mentioned it already. Maybe I did actually, that if you define here a label, that is going to be a label, I don't know which one, then you can choose which label to define with that specific feature. So we can see, I think it's good to see that, okay, this is what is predicted in the end, but this is what are the importance points I got for this label or that label, and that is also a good feedback to see, okay, this sentence was trying to get predicted into that label or this label, but then it ended up using that one instead.
Yeah, so as an example, then if it didn't feel like it picked the right thing, so if it, for example, would have picked government in this case instead of telephone, you would have wanted to put in government and understood why did it not pick.
Yes, exactly.
Or you would have put in telephone and understand why it did not pick that.
Yes.
Cool. Yeah, I think this is very, very interesting.
Yes, and I can't wait to get the new extended, updated code and everything, so we can play more with it. And yeah, so I'm going to update my blog post accordingly to what I showed just now.
That was really nice, a really cool piece of software to explain it. So where can we see you next?
So yes, that's a good question. When will you see me next? You will see me next month, I think. If I remember correctly, in the beginning of June, I'm going to show up at one smaller meetup, and then I'm also going to show up. Where will I show up? I have like 2 sessions in June on the 3rd and 4th as well, and I'm always tweeting about it or writing it out on my Facebook page as well. It is actually visible on my blog too, so I am very easy to get followed.
I will post the blog again in the chat. Here you go. So thank you, Eve, for taking the time to show us that. That was really nice.
Thanks for the invitation.
Talk to you soon.
Yes.
So our next guest and next topic is Sami, who is going to talk about confidential machine learning.
And I think Sam is joining us from a bar.
Yeah.
He's showing up.
Here's here right now. So, Henk, I am the topic.
Yes, so let me first put you right in the show, because I messed that one up again. So in the meantime, while I'm trying to fix your video, you can tell who you are.
Okay. Yeah, so you mentioned my name already. I'm also an AI MVP since the 1st of April, and it's not an 1st of April joke, it was for real. I'm a senior consultant and managing partner at Arinti, which is a Belgium-based firm that focus on the Microsoft AI stack. So we work with chatbots, but also building machine learning algorithms for smaller to bigger companies. And as an AI MVP, I try to speak as much as possible on community events, write some blog posts once in a while. And for the global AI community, I'm the main host for the AI Talks Live, a weekly YouTube live show where we invite speakers to discuss a specific topic.
That is cool. Tell me a little bit more about those AI talks you are doing.
Okay, so it's an open public. Everyone can just join on YouTube. We mentioned them on Twitter, so if you want to figure out when it's going on, just follow me. Is there something wrong with my video right now? Okay, it's fine. We also have our meetup page, or go to our globalai.community/AI talks. There you will also find an overview of all the talks that are coming up. On our YouTube channel, you will find all the videos that have, all the talks that have happened already. So you can always look back to some great talks. Like even tonight, we're having a nice talk from someone from Amsterdam, Emma, and she's going to talk about how to, well, communicate through abusive text messaging on Twitter. And next week, for example, we have someone from the US from university, and he will talk about how to create games with AI. So I'm really looking forward to those two talks.
That sounds really cool. So follow you on Twitter, and I think it is YouTube/Global AI Community. Something like
something like that. I would need to check the connection, but you can always find it on our Twitter channel or on the Global AI Community.
And we will put it in the it in the chat.
Great.
So cool. You are going to talk about confidential machine learning. So the first question would be, what is it?
Well, we all know that you can do a lot of cool stuff with AI. It can enhance our life. It helps organizations to get more productive. And if you look into the current situation, we see a lot of people trying to build machine learning models to predict if someone has COVID-19 or not, based on the pictures of their lungs. Now, if we stay in the medical industry, a sector where confidential ML can be very interesting, is that, well, ML or deep learning models, they stand or fall on the data behind it. So the more data we have, or even the more distinct data we have, the better the predictions can become. Now, with medical data, that can be very hard because of privacy concerns. Let's even say any personal data, because you don't want to lose the trust of your customer or patient. Now imagine your medical records would just be public. You don't want that. Now imagine you can share that data with others without the other parties being able to read your data. And that is actually what confidential ML makes it possible. So that way Hospital X can share his data with Hospital Y or to a university without giving access to that data. Another example then, more for not in the medical, but just for you and me, is let's say you are looking up a coffee shop in your neighborhood. Well, actually, you're already giving away your location online, and then you're also telling them where you are. So by making use of confidential ML, you are sending your location encrypted to the server, and it will respond also with an encrypted location. So the server doesn't know anything of what you've been recommended, but also doesn't know where you are. Of course, for recommending engines, that gives some issues, but from use case to use case, we can use this. So at the moment, there are many technologies that can help you secure your data in rest, encryption on a database, on your storage. And we have encryption during transfer on network with SSL, for example. But the missing link is confidential machine learning. So where we also have the data encrypted during compute. And that's what confidential ML is.
Cool. Thank you for that explanation. That was really clear. But
that's extremely useful, I think, because we've had we've had many cases that we've been working on where obviously you can't even do machine learning on some of it because you have to obfuscate a lot of the data, and it's quite difficult to obfuscate the data. So having something like this is a game changer, I think.
Yeah, exactly. So if you then would think of so some people that really actually sounds a bit like magical. How can you do calculations on encrypted data? But it's not that magical anymore if you think about how encryption works, because encryption is mathematics, right? So there are ways to encrypt, to use that encryption math to, in the back end, actually use the real values to compute certain calculations. So that way we could have encrypted value A. We want to do an addition with encrypted value B. And then we get a new value, which is encrypted value C. And you didn't see that data, but you actually have calculated. So to do this kind of specific encryption technology, you have a specific technology that is called homomorphic encryption.
Okay, tell me more.
Well, one of the solutions that are there is Microsoft Seal. And just to give a quote of what the GitHub README says, it's an easy-to-use open-source homomorphic encryption. It's developed by the Cryptography and Privacy Research Group at Microsoft. And the main concept of Seal is key generation, encryption and decryption, and of course the semantical evaluation. So actually it's a library written in C++, but they also built a wrapper around it for C#. I'm glad that it's also in C#. I'm not really into C++, but let's have a quick look of how it actually can be done. I need to share my screen. Give me a second.
Getting the YouTube, the link to your blog.
Okay.
Already in the chat. And let's switch to your screen.
Yeah,
there you
should
go.
Be able to see it. So I made a small example. First of all, within Seal, you have two different schema types. And the schema types are BFEs. This is the one I'm using here at the moment. And that's to, it allows modular arithmetics to be performed on encrypted integers. So for applications where exact values are necessary, then BFE is the scheme that you need to use. Another one is the CKKS scheme, and that allows additions and multiplications on encrypted real or complex numbers, but it only yields back an approximate result. So in applications such as summing up encrypted real numbers, evaluating machine learning models, well, then CKKS is the way to go. Now, that's the first thing we do. We set up what scheme that we would like to use. Now, the second part is the polymodulus degree. It's all difficult words if you're not into math, but the polymodulus degree makes the ciphertexts, the size of it larger, and it makes, well, an operation slower. So it enables more complicated encrypted computation. So the bigger you do make it, the more complicated compute that you can do. Now this is also always from square 2, the numbers. Now we also have the QUIF modulus, and that implies a larger noise budget and hence more encrypted computational capabilities. And then I will also explain later on what the noise budget is, because that's something really important. And then you have the plain modulus, which determines the size of the plain text data. So, and the consumption of noise budget and multiplication. Thus, it's essential to try to keep the plain text data type as small as possible for best performance. So the bigger all these values are, the slower your computation will also work. This is the hardcore stuff, you could say, because this needs to set up before. Now, the first thing we need to do is we want to encrypt our data first with homomorphic encryption. So we need to create a key generator based on the context that we created. Now, then we have our public key and our secret key that we need to create. Again, with homomorphic encryption, symmetric and asymmetric encryption is perfectly possible. So once we have our keys and we can go to the next step. So there we are going to generate our encryptor object, where we give back our context plus our public key. So, and then we have an evaluator, which will actually do the code, the mathematical solutions that we want to do. And then we have our decryptor if we want to go back and see actually what the result is. Now, in this example, we say we have value x, which is 2, and we have value y, which is 4. Now, I generate a plain text object for it, and I add it into it. This is just some logging that we will see when it's running. Then we encrypt it. So we create the ciphertext, and then we say, okay, encryptor, we have our explain, or x value, and we want to add it into our ciphertext x encrypted. And we do exactly the same for y. Now, each ciphertext has a specific value of 2. And that size is also depending on the configuration you did in the top. Now we want to generate the result of our, for example, our addition. So we create a new ciphertext and we say, okay, evaluator, and that's the object that we need to call to do the math. We want X encrypted plus Y encrypted, and the result of it you need to save within results. So what we're doing here is, as I said before, we have value X that is encrypted, but value Y that is encrypted, and we are generating the result that is also encrypted. So again, I'll just show up what's the size, and then we want to convert it, so we decrypt it into plain text, and that way we can show it. Now let's run this code. Now for value 2 and 4, you see the size is here is of 2 each other, and then the result is also 2, and the result is actually 6. Now, as I discussed also, we have a noise budget here of 54. The lower this gets, the harder it is to decrypt your value. And then you can get issues with the results. To fix that, you can do, it's called a relinearization, which actually looks into the value again and put somehow a reset on it. So you can do again new steps.
Sammy, we got a question. What if we can't decrypt it?
Sorry, say that again?
We got a question asking, what if we can't decrypt it? Would that ever happen?
That's possible, yeah. But then you need to look into fixing your configuration on the top. And as I said, maybe you need to do relinearization in between. Now, in this case, it's just one function that I call, so I only do an addition. But if you have complex calculations that you need to do, you actually need to do it in different steps. You cannot just, okay, this is my formula, just run it all at once. Does that make sense?
I think so, yes.
Okay. Now, what is also cool is, okay, we have now encrypt 2 times encrypted data, but now imagine we also have data that is not encrypted that we would like to use too. Now, in that case, I will change my Y encrypted to my Y plain. So we have encrypted data and we have non-encrypted data. So I have another function here. It's called add plain. And if we run this, boom, boom, boom. It's acting up. Just close it and run again. Okay, here it goes. And we have exactly the same result. So that means, for example, you have your own data that you're the owner of, and you have data from, well, let's go back into the hospital example. Your data is not encrypted, but from your sister hospital, it is encrypted, that you can still combine those two also.
Very cool.
Sorry.
No, I said that was very cool.
But the only challenge that we have, well, you're calculating on encrypted data, so it will always be slower than just on normal, on normal data. But over the time of development of Seal, they've already really increased incrementally the performance by making use, for example, of hardware acceleration. But it's always going to be slower. And
will it also be less performant in terms of accuracy and things?
Yeah, exactly. So yeah, it's still on. Yeah, you will not have always exactly all the data, but there are some tricks to still work with that. what I wanted to show also is that one of the big challenge also is that the number of kind of calculations that you can do is quite limited. So if you look at the evaluator, you have like additions that you can do. You can do complex stuff. You can do multiplications, the relinearization that I was talking about, or square subtractions, and to transform it.
I think we need to start wrapping up a little bit because we also have Alicia talking about white noise, and we only have around 7 minutes.
Yeah.
To go, so.
Okay. Well, except Seal, there's also another solution that we can use, and that's actually a hardware solution. So there's there we have more options, but that solution is called Open Enclave, and it's actually a collaboration between Microsoft Research, Windows, and Azure. And the fundamental concept of it is that you create a trusted execution environment, or a TEE, and it's some kind of black box where you put your code in and your data, and the code can only, well, the code within that black box can only talk to that data and no one else. But there it gets encrypted within that small box. That's possible because of specific CPUs, like the Intels with the SGX extension, so the software guard extension. AMD also has released specific CPUs for that. Now, the cool thing is those CPUs, those CPUs are available on Azure through a VM series called the DCV2 series, which got general available also here on the builds. So there are limitations to both of the items, but things are moving, and I'm sure over time it will get much faster and better.
Cool, and I think everyone is more explained on your blog, a little bit more in depth.
Yeah, more in depth will come later on my blog also. So if they keep following me, they will pick up a new one.
So keep following Sammy.
Yes.
Cool. Then Alicia has to break a record and talking about white noise, what it actually is, in like 5 minutes. Because then we're going to go to Brian. So Alicia, a very quick introduction and then just dive into the code.
Yeah. So hi everyone. I'm Alicia Moniz. I'm a new Microsoft AI MVP. My background is in data warehousing, reporting and analytics, and nowadays I spend a lot of time architecting solutions in the cloud with our clients. I'm currently working with the teams at Avanade, and it gives me a great opportunity to touch and play with all of the Microsoft tools whenever I feel like it, and I get to spend all the time that I want with Hank and the team. So when I'm not working, you can find me at the Global AI community. So today, I'd like to talk to you just a little bit about the white noise libraries. And this was a great topic for me because I'm not as in the weeds as everybody else on the call with the machine learning, but I have these conversations all the time, and privacy is a conversation that's top of mind with everyone. And I'm working with these data professionals, and I'm working with these data scientists, and we're constantly looking at ways to expand and optimize our use of the Microsoft ecosystem so that we can grow with our use cases. So when you look at the ecosystem of people who are using data science projects and touching data science code and touching data science data, it's not just this small team anymore. It's AI is going to permeate throughout the organization, and data professionals are going to start mixing and blending in there, and our business analysts are going to start mixing and blending in there. So it's really useful to know what you can add to your toolkit. So just to skip through, and I think I'm sharing my screen, Hank. Okay, so I'm ready to go. So I have, I'm just going to skip through and show you a little bit of two things. Okay, so one is the core and the system. So if you are familiar with a differential privacy system and you do have that team of statisticians that work for you, then you're familiar with this model. Users get assigned a budget that checks against the budget store. We'll go ahead and add some private data and some noise to that, and then you get a report which adds visibility into the results and as to your methods for generating the data set. And this is a whole bunch of algorithms that runs in the background. So the white noise project will go ahead and provide you with that core, with those underlying algorithms. And number two is it will also provide you reader bindings so that you can go ahead and share these capabilities with your data consumers and have protected SQL queries being conducted against your data set throughout the organization. So in the interest of time, I can go ahead and step down through some of this code. So we're going to go ahead and import from the OpenDP white noise library set here. This is importing from the core. We'll go ahead and build out our data set and clamp to our upper and lower bounds. And the algorithms do require that you have a fixed and defined amount of data. And there's also some nullity checks down here. And I can also go ahead and generate my histogram at the bottom. And I'm keeping an eye on the time. And let's just kick through to the histogram.
So while you're doing that, the whole purpose of this is then to introduce white noise so that the original, like, so you can't sort of like figure out what a specific person, what their data is.
Yes, and the whole, I found it was interesting, the data budget. And the theory is if you make, you can do a set amount of queries against a data set, and after a period of time, you can recreate the underlying data set, even if you don't get the full result set back with each query. And so that's part of the whole budget store, is we're restricting how much of that data you get back. So really quickly, this is the second part. This is the SQL data access part, where we're going to go ahead and parse that query. We'll do some rewriting to make sure that it satisfies differential privacy rules. And there's a little bit of a wrapper. And the kind of the thing behind this is, so we're wrapping Pandas data reader, and this is within the Python libraries. And you see by the amount of code there that this isn't a big departure from the way we're currently utilizing code, and is extensible and something that we can hand off to our data consumers. And I think we're about out of time. So thank you, and looking forward to sharing more about the white noise library in the next couple of days. So thank you.
Thank you so much for that, Rush.
That must have been a record. Thank you for doing that. And that is, of course, I've shared more information in the chat about the white noise. So if everyone is still on the call, we can just do a wave to everyone. I will switch it back to Willem is, of course, now actually talking about the same topic on the build live stream. So we can wave bye, everyone. So thank you all for watching, and don't forget to tune in to Learn TV every Thursday at between 4 and 7 Central European time, and learn more about AI.
Yeah, and I also want to thank everyone who was on the chat and chatting along, asking questions and things.
Hey, my name's Akanksha Malik, and I'm from Melbourne.
Excellent Somi, it's Bal here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, you're the test. I come from Spain.
I'm Prasant from California.
大家好，我是卢建辉。
Ik ben Willem uit Nederland.
I'm Alpha Cassidy from Australia. Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi,
I'm Matthew Renton from the USA.
I'm George Bizak from California.
Hi, Midi Eddie Daoud, Greece, Africana.
Hi, I'm Ana Famana.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there.
Hi.
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 Hi. Hi.